Hi, I'm Steve Murphy, and I'm a Vice President at ARG. We're going to explore SD-WAN in some detail. And this is important to IT engineers, networking engineers, whether or not you're managing 1,000 sites or just a single site. SD-WAN has a story that you might be able to incorporate into your wide area networking or other networking needs. There's a lot to cover, so we're going to break this conversation down into three separate videos. Today's video is about what is SD-WAN. We're going to conduct an entire video just on the benefits of SD-WAN, and then we're going to look at the business case for SD-WAN. How do you describe this to your management team? How do you look at the financial implications? And how do you get approval to be able to deploy SD-WAN into your organization? So first, to understand SD-WAN, you have to understand what we've been doing for wide area networking over the past several years. And wide area networking has been pretty traditional. We're going to put a couple remotes and a data center that these remotes need to connect to. Now, in the early days, this might have been a private line, or otherwise known as a point-to-point. That could be EVPL, which is our Ethernet Virtual Private Line Service. Could be dark fiber. Could just be, in the old days, a traditional TDM circuit. Now today, most people might have a few private lines in their network for specific types of traffic, like replication or something. But in today's networking environment, most people, to connect their branch offices with a data center, are using MPLS. MPLS has been around for about 15 years, and it is a standard, tried and true, private but relatively flexible wide area networking technology. So we like private area networking in this regard because it controls the elements that we need to provide good service to our end users. Things like latency, loss, and jitter. We have very good performance over these private networking topologies for these key performance metrics. The challenge with MPLS is that it can be expensive. One of the ways that we manage expense within our network today is that we are bringing all of the traffic to a data center, which has a corporate security platform built into the data center. So all of our traffic flows to the data center where it can be treated for security in a central manner and then be sent out to the internet. So this keeps us very secure, keeps us with a very consistent, uniform security profile and platform that we can manage, and that reduces our risk. Beyond the cost, one of the challenges of this network type is that generally for MPLS you need a single provider. So no matter whether the MPLS service provider can get to a location or not, or at what cost, you have to use that MPLS provider. So you are locked in to a provider, and you are locked in or held somewhat hostage to the cost structure that they have with each of these remote locations. It's also inflexible. When you need to open up a new location, you might have to wait months for a new MPLS connection to show up. Whereas today, with internet, you can order a broadband circuit and be up and running in probably a couple of weeks. It's also management intensive. IT engineers have to map past individual locations to ensure that they are properly connected and properly managed. The applications are properly managed within the PVCs that we're putting over the MPLS network. So it works for now. It has some limitations, and there are some better options within the SD-WAN product set that can help us move into a more consistent topology for our users as they move out to the cloud. And that's what's really been transforming the way we network today, is all the applications that are living out in the cloud. Because today our users really aren't going to the data center as much as they had in the past. They want to go to Azure or AWS. They want to access things like Office 365 or Salesforce or Box any of the other SaaS applications that are out there. And today they need to go through your central security platform at your data center to access these applications. That creates latency, it creates congestion here, it creates points of failure that as an IT organization we need to manage. So there is a better way to allow our end users to connect directly to the internet to access those services. And that's what SD-WAN tries to accomplish. So if we want to allow our end users to access these resources out on the internet, the network gets very complicated. If we're going to continue to pass traffic through our security platform, we need to then very carefully manage the user experience as they're moving out and utilizing some of these applications. Another complexity is what we have at the edge of our branch offices. Typically, we're going to have a stack of appliances here at the edge. That stack might include routers, a firewall, because even though we're providing security at the data center, we're going to have a firewall whenever we're connecting a public internet connection to our network. We're going to have potentially WAN optimization, and we're going to want some site-to-site stuff, some site-to-site connectivity, so we might have a DMVPN. So all of these services are being deployed at each one of our branch locations, creating a lot of complexity, as I said, and a lot of cost structure that we have to have. Not only are we putting individual appliances there to support those services, but we have to provide care and feeding of those services over time, which further increases our cost. Management becomes tougher as the number of sites increases, and it's really not the best topology that we can come up with in this day and age. The primary benefits is that it's private, and you only are using the public internet maybe when you have an MPLS service issue, and you're connecting over a VPN as a failover. But most of the time the internet connection from these branch offices is unutilized or underutilized. While we're showing you here connecting to the internet, that's true, we're really not utilizing those connections for access to the internet because we're still going through our security stack at the data center. So if we need to, we can use the internet to reach the data center, get security applied to it, and then go back out to these applications. We really haven't improved our performance metrics going to these applications by adding an internet link in this network. So one objection that we can get when we talk about how we are constructing a bottleneck or a congestion point at the data center and hurting performance of accessing some of these resources that our end users want to reach are, well, who cares? Because these are not time-sensitive resources typically. I would argue that Office 365 is getting very time-sensitive, but Salesforce, Box, accessing resources in Azure or AWS as an end user may not be time or latency sensitive traffic, but we're putting more and more out into the cloud, not just these resources, but we're doing UCaaS, which is essentially hosted voice or hosted PBX. We're doing collaboration, which is frequently video and very much a real-time application. And again, some of our applications, productivity applications, are becoming time sensitive. So because we are pushing more and more applications and more performance sensitive applications out to the cloud, our traditional topology is becoming less and less relevant. It's being challenged by the changing nature of the traffic flows on our network. So we need a simple and affordable solution. That's where SD-WAN comes in. SD-WAN stands for Software Defined Wide Area Networking. It combines all of our requirements into a simple and affordable platform. Let's start the conversation here at the edge, where SD-WAN collapses all of these services into a single appliance that provides a number of advantages. So SD-WAN can clearly do routing. Most SD-WAN platforms have a very robust security offering. the SD-WAN device can do compression and deduplication, and it can support secure site-to-site communications. Now, all these services are optional. You don't have to utilize those services. If you like your firewall platform and you want to keep it, there's additional residual value left in that platform, feel free to keep your firewall in place. Same with your WAN optimization. But as those age out, you have the option of turning those over to the SD-WAN platform at a very affordable price. Aggregating all of these services into a single device is that you now have a single control plane where you can orchestrate the entire network through one user interface. Makes things very efficient and actually reduces risk quite a bit. So once we're done talking about the edge, the network itself can become optimized. Today, as I mentioned, we are constrained by our single MPLS provider. Going SD-WAN, which is traditionally an internet-based service, you then get independence, and you are agnostic as to who you use as your internet service provider. You can use the most cost-effective provider at each of these locations, and you can use different types of internet. You can use fiber-based internet, dedicated internet. You can use business class broadband, which would be either a cable connection or a low-cost fiber connection from some of the ILECs, or even going back to DSL in some hard-to-reach places. You can also use wireless. 4G or 5G wireless is also a great add-on to an SD-WAN platform. You have to be careful about the usage. You may not want to use that as your primary connection, or you may not want to load balance too aggressively on that wireless, but as a failover where you're only putting data on that wireless network when you need to do so to keep your costs down, can be a very effective strategy to keep people up and running with their mission critical services. So what do you lose when you go to an SD-WAN? Let's just say that we've gone from MPLS to the public internet. So we essentially have redundant internet connections here. What do you lose? Well, you lose quality of service because we are no longer managing over a private network the packet loss, the jitter, the latency of services. Now, it's been our experience that you can manage those very successfully going over the public internet with an SD-WAN platform. The SD-WAN service will test each network and determine which application should ride which network for the best performance. Or there are service providers out there that have SD-WAN platforms, but they also have a private network. So you're going over the public internet for a very short period of time until you jump on their private network, and then that private network is managed for quality of service, just like your former MPLS network. So we do have options in terms of managing quality of service for your critical applications. Again, it's been my experience that going over the public internet is sufficient for most applications. We do have some great information from customers doing side-by-side tests of SD-WAN in their traditional production network, including MPLS networks, to show that a private network can enhance the throughput and the performance of what people are currently using today. So that's another option. Now, a lot of our clients won't go to the internet immediately with their SD-WAN deployment. Some will keep their MPLS networks in place and slowly migrate applications to the internet side of the SD-WAN device, just to make sure that they're moving forward in a very logical and very thoughtful way. And that's fine. Most SD-WAN platforms, in fact, virtually all SD-WAN platforms today, will support MPLS, will support point-to-points. So you can keep your private network for a period of time, and it gives you a very smooth migration path from the traditional topology that you're running to a more accommodative topology for all of the services that are currently going into the cloud. Security, as I mentioned, firewalls typically incorporated, but IPsec is used by all the SD-WAN providers, so the traffic is secure. You get agnostic internet access providers, as I said before. It is simple and inexpensive, and we're going to go through the actual benefits of SD-WAN in the next video. We'll jump into some more detail about what you actually get out of SD-WAN from a management perspective and from a performance perspective. If you like this video, I think we've gone through enough at this point about why SD-WAN is so important, why the traffic is moving out to the internet, and how SD-WAN assist organizations in getting to that traffic directly. If you like this video, please feel free to subscribe so you can come back and find the additional videos that we're publishing on these and other topics. And if you want to leave a comment or like us, I'd appreciate that as well. If you're considering SD-WAN as a project right now, you can also reach out to me. I'm happy to have a conversation with you about what your ambitions are, what your project looks like, and we can talk about what some of the alternatives are that you might have. Happy to have those conversations, and I look forward to seeing you next time. Thank you so much. Bye-bye.